The second equation, where we see x, what do we think we have to replace it with? Negative 9 plus 3y. So that takes the place, see the x right here? It becomes this because it's equivalent. Okay, and then we still have the minus 5y and the equals 5. Can we solve this equation now?
Yes.
Yes, there's only one variable. Once we have one variable, we can solve. First step would be to do what? Distribute. So negative 45 plus 15y minus 5y equals 5. Yeah, that's from up here. See, the equation was 5 times whatever x was minus 5y equals 5. Is that okay? So now if I combine my like terms, negative 45 plus 10y equals 5. I'm going to add the 45 to both sides. 10y equals 50. Y is 5. So how do we find x? So that was step 1. This was step 2. The solving is step 3. Step 4 says find x. Find the other variable. We substitute in. Where do we want to substitute in? For the first one. So x minus 3 times 5 equals negative 9. X minus 15 equals negative 9. I add 15. X equals positive 6. What do I do next? Step 5. Once I have my answers, what am I going to do with them? Check them. So the first one is x, which is 6, minus 3 times y, which is 5, equals negative 9. 6 minus 15 equals negative 9. Check. And the second one is 5 times x minus 5 times y equals 5. 5 times 6 is 30. 5 times 5 is 25. What is 30 minus 25? 5. So the answer is 6, 5. Always list x first, right? We're writing a coordinate, so x then y. So if you're solving a system of equations and the variable is not already isolated, so you have to do that extra step and get the x by itself. After that, it's the same process every time. So then we talked about on our graph over there, we can have all solutions or no solutions. So let's look at what happens what it looks like on these problems. So infinite many solutions, if you solve the system and the result is true, we've talked about this before with solving equations. Okay, so let's start with this one. What's the first step we have to do? First step we have to do is get a letter by itself. Do we want to use the first or second equation to do that, Adam? The first. So we're going to take the x plus 3y equals 6, and we're going to solve for which letter? Maddie? X, because x is already kind of by itself. It doesn't have a number. So we're going to minus the 3y. So x equals 6, take away 3y. Don't minus that because those are not like terms. You just list it as 6 minus 3y. So that's step 1. Step 2, we're going to replace the x with what? So we replace the x with 6 minus 3y. So it's 2, 6 minus 3y plus 6y equals 12. If you do this correctly, you should only have one variable at step 2. Okay, we replace the x up here with the equivalent value to x down here. And now what do we have to do to solve this? Distribute, yeah. So 2 times 6 is 12. 2 times negative 3 is negative 6y. Plus 6y equals 12. If we combine our like terms, what does negative 6y plus 6y equal? 0. So we end up with 12 equals 12. Everybody see that? This negative 6 and the plus 6 disappear. They cancel each other out. And 12 is left here and 12 is there. Is 12 equal to 12?
Yes.
Yes. So what is my answer going to be? All are infinite solutions. No matter what number we plug in, it will work. No matter what set of numbers. So this would be, if we graph this, the same line. If we graph these two, they would have the same line.
Wait, if you say all solutions, would it just be the whole entire graph?
Any value that you pick on that would work. Yes.
What, the graph or the line?
On the line.
The whole graph is a solution.
So I guess the better way, infinitely many actually works better because it's just saying it's not really every solution. For these, it's not every solution in the world.